We'll start our similarity unit by talking about ratios and proportions. A ratio is a comparison of two numbers. Now we write a ratio, we could call, for example, the ratio of the big triangle to the little triangle is 3 to 1. We could write it as a fraction, we could write it with a colon in between, or we could actually write the word 3 to 1. So ratio is a comparison of two numbers, and we often use it in similarity as a scale factor, which we'll talk about. In a triangle, the ratio of the measures of the sides is 8 to 7 to 5, and its perimeter is 240. Find the length of each side. While you don't need to draw a picture for this one, we will. If the ratios are 8 to 7 to 5, I can label each side as 8x, 7x, and 5x. And then I'm going to figure out what x is. The perimeter is 240. Remember, the perimeter is when you add up all the outsides. So I'll say 8x plus 7x plus 5x, which is 20x, equals 240. Divide by 20, x equals 12. So now I can go back and find the length of each side by plugging in x equals 12. The 5x side would be 60, the 7x side is 84, and the 8x side is 96. And you can double check that these three numbers do add up to 240. A proportion is when we just set two ratios equal to each other. So I'll write it as the equality of two ratios. So for example, it would say A over B equals C over D. That's a proportion with an equal sign in between. We have what's called the cross products property. Some teachers have called that cross multiplying. That's when we multiply A times D, and that's equal to B times C. And that only works across an equal sign. Don't try that across any other sign. And then we solve for the missing part. So for example, over here, we have 3 over 8 equals x over 32. We could cross multiply. 3 times 32 is 96, equals 8x. Divide by 8, and you should get 12. Now I'm sure a lot of you looked at that and you said, well, I could just look at it and scale it. 8 times 4 is 32. 3 times 4 is 12. Yes, you can. If you have a proportion that can be scaled, go right ahead. That is a quick way to do it, and you don't have to do the multiplying. However, we get to a problem like this one, and you can't scale x plus 1 to 6x. So we have to use the cross products. So I'm going to multiply 1 times 6 is 6x. Then I'm going to multiply 4 times x plus 1. And don't forget, you're doing the distributive property when you have something like that. You have to multiply 4 times x and 4 times 1. And now it's just algebra. Subtract your 4x, divide by 2, and x equals 2. So we can double check these. I always like to do that. Plug the 2 back in. You would get 1 over 3. And if you plug 2 into this side, you get 4 over 12. And you can confirm that that really is equivalent. So that's how we solve our proportions. Let's move on to similar polygons. Similar polygons have two special things about them. All of their corresponding angles are congruent, and all of their corresponding sides are in proportion. So for example, you can look at this picture. I said quadrilateral ABCD is similar to, symbol for is similar to, is just that squiggly line, GHIJ. So what that means is angle A is congruent to angle G. Angle B is congruent to angle H. Angle C is congruent to angle I. And angle D is congruent to angle J. The order of the letters is very important. It tells us what corresponds to what. So all of the angles are congruent. It's the same shape, but they're different sizes because the sides are in proportion. Remember, congruent shapes were the same shape but the same size? Similarity is they're the same shape, they're just different sizes. One is an enlargement of the other. When we talk about scale factor, it's important. The scale factor is the ratio of the image to the pre-image. The pre-image is the original, or the first one. The image is the new one. So when we talk about scale factor, we want to know the new to the old. So if I was looking at these two shapes, let's say AB was 7 and GH was 14. CD can be 9. This would be 18. We'll make this one 5, and we'll make this one 12. I'm just making up numbers. So you would look at the ratio of these. So 7 to 14. So when I ask you for the scale factor, this would be my image. This is the new one. This would be my pre-image. This is the old one. So if I asked you what's the scale factor of these, you would be going from the little one to the big one. So you'd say 14 over 7, or 2. In other words, I have to multiply the original figure times 2 to get the sides of the new figure. So 7 to 14 was times 2. Image to pre-image. And then I can find any missing pieces. If I know the scale factor is 2, then 5 times 2 is 10. 12 times 2 is 24. So my scale factor here was 2. Image to pre-image. All right, here's an interesting question that comes up, and it's kind of an SAT kind of question. It says, find the ratio of x to y. So I've given you an expression or an equation here, and I just want to know x to y. So here's what we do. We do our cross products. 3 times x plus 2y. So remember, we're going to distribute. 3x plus 6y equals. Then we multiply the others. 5 times x plus y is 5x plus 5y. Don't forget to do your distributive property, and there's just an equal sign in between. Now, in order to find the ratio of x to y, here's the process. Let's get all the x's on the same side and all the y's on the other side. So I'm going to subtract 3x from both sides so that all my x's are over here on the right. And then I'm going to subtract 5y from both sides so that all my y's are on the other side. I don't care if you get them on the right or on the left, just get the x's and y's on opposite sides. Now my question is, what's the ratio of x divided by y? Well, I need to get the y underneath the x. So I'm going to divide both sides by y. Now, y divided by y is 1. So be sure you leave a 1 in that place. Now the right side says 2x divided by y. But my question was, what is x divided by y? So I need to get rid of that 2. And the way we're going to get rid of that 2 is we're going to divide both sides by 2. 2 divided by 2 is 1. And on this side, I have 1/2. So the ratio of x to y is 1/2. So whatever expression they give you, you make it into an equation. Get your x's on one side, your y's on the other. And then it's just division to get it to say x over y equals a number. And if you wanted to make up numbers for x and y, you could plug them in and just check them and say, okay, x to y is 1/2, so maybe x is 3 and y is 6. Plug those numbers in and see if it really gives you this ratio of 5/3. So this is a good one to practice because it will show up again. One more example. The area of a rectangle is 2,028 square meters. Now I know the formula for a rectangle is length times width, or base times height, right? Base times height. But all they told me was that the ratio was 3 to 4. So we're going to apply something similar to what we did earlier. I'll say this is 3x, and this one could be 4x. So I multiply base times height, or length times width, and get 12x squared equals 2,028. Please remember, 4x times 3x. 4 times 3 was 12. X times X is X squared. Don't forget that part. So now I'm going to divide both sides by 12. 2028 divided by 12 is 169. And if you don't know that one, the square root of 169, just ask your calculator. The square root of 169 is 13. So X is 13. Let's find the length and the width. 4 times 13 is 52. 3 times 13 is 39. And double check that. 39 times 52 really is 2028. So do some practice on this one. There's not a check yet. So you need to do one more set of notes before you do a check. But do some practice on ratio and proportion.